Hello friends, welcome back to our channel. So in today's session, we'll see one more error detection mechanism in computer networks, that is a checksum. So in our previous sessions, we have seen what is an error and what are the causes of errors. And also we have seen a few techniques for error detection. So here also today we'll see one more error detection mechanism, that is checksum. So let us start. So here, as the name itself indicates, this is an error detection mechanism. It will only detect the error. That means whether the data which was sent by the sender is received by the receiver exactly or not. If there is any data corruption during the transmission or not. So for this, so there are few steps involved in this checksum. So one is a sender side, another one is a receiver side. Sender side and receiver side. So coming to the sender side, first it will divide the complete data into different blocks. Okay, so step 1 divides data into n blocks. Okay, divides the data into n blocks of fixed size. Okay, all the n blocks will be of fixed size. And after that, step 2 perform once complement arithmetic or addition on all n blocks. So this is not a binary addition, but it is an once complement arithmetic addition. Okay, arithmetic or addition. So that means if you add 2 bits, if you had one carry, and that carry should be again added to the LSB of that particular result. That is called as a once complement arithmetic. Okay, so for example, let us take bits 1, 0, or simply we can say 1, 1. Okay, so if you add here 1, what happens? This is a 0 and it will go here, and it again 0, it will go here, and it again 0, and this is a carry bit. Okay, this is called a binary addition. This is called a binary addition. Okay, so if this happens, okay, if this happens 1, 1, 1 and 1, 0, 0, 1. So this is in this one. So this, if you apply the binary addition. So if you apply the ones complement addition 1, 1, 1, 0, 0, 1, and if it is ones complement arithmetic, so what happens here? See, this is a 0 and this 1, this is 0 and this is 1, 0, and this is 1, this is a carry. So here also it is a carry. So we'll just ignore this carry if it is a binary arithmetic, and if it is ones complement, this 1 should be again added to LSB of the result. So here it will be 1. So 1, 0, 0. So this will be the ones complement arithmetic for these two things. Okay, if it is a binary arithmetic, this is the result. If it is a ones complement, whenever the carry is obtained, that carry will be again added to the LSB of the result. So this ones complement arithmetic should be applied on all n blocks. Okay, so once it was done, we will be getting the result, final result. Okay, so we'll get final sum after step 2. After step 2, we'll be getting the final result. And step 4, apply once complement to final result. So this is nothing but our checksum. Then what is the step 5? add data, or we can simply send data plus checksum to receiver. So this should be sent to the receiver. Okay, so hope you understood this one. So first we will divide the complete data into n blocks of fixed size, and then perform the ones complement addition or arithmetic on all n blocks, so that we'll be getting only one result, that is a final step, final sum, and apply ones complement to the final result, which is nothing but a checksum. And now we have to add the checksum to the data, and it should be sent to the receiver. And at the receiver side, so what is the step one? Again same, divide data plus checksum into n blocks. This is also fixed size. So the same steps, whatever the steps we have done in the sender side, the same thing. So again, perform ones complement arithmetic. Ones complement arithmetic. Okay. On all n blocks. On all n blocks. Step 3. What we have to do? So final step. Step 3 is a final sum after step 2. Step 4. What we have to do? Apply ones complement. Apply ones complement. Okay. So step 5. This is the most important in the receiver side. Step 5. Verification. Verification. So if result of step 5 is all zeros, that implies no error. So that means if we perform the sum, okay, ones complement arithmetic on all the n blocks on the receiver side, and applying the first complement, ones complement, if you get all zeros, that implies there is no data error. I mean, there is no error done during the data transmission. And if result of step 5 is not all zeros, then it implies this is an error. There is an error. Okay, so during the transmission, some bits have been errored. Okay, flipped. Error means the flipping of bits. Right? Hope you understood these steps on sender side and the receiver side. So now we will check one example. Okay. So let us solve this example. So data here, the data block, 4 blocks are there. So in each block, the block size is 8 bits. Okay, fixed it is an 8 bits. So here you might be having one doubt that if the complete data is not able to divide it into fixed number of blocks, then you can apply the padding. So that means adding the dummy bits, zeros. So where you have to pad these 0 bits. So you should pad these 0 bits on the right hand side only for this checksum in order to find out the error detection. Okay, so that means, for example, if the number of bits are 12, number of bits are 11. Okay, number of bits are 11, then and these bits are divided, if you want to divide these bits, okay, into 3 blocks. So how many bits you can have? Here 4 bits, here 4 bits, and here 4 bits. But unfortunately here we are having only 11 bits. So here we will be getting only 3 bits. So what we have to do? So we have to pad 1 bit, pad zeros on the last, that means right hand side. Okay, so that should be done. And if the number of bits are able to divide into fixed number of blocks, there will be no problem. So here there is a data. Now sender side, during the in the sender side, what we have to do? So we have to apply the ones complement addition. So I am taking B1 1 0 1 0 1 0 1 0 and B2 1 1 0 0 1 1 0 0. So I need to use ones complement arithmetic. So ones complement arithmetic, this is 0, this is 1, this is 1 and this is 0 and here it will be 1. So it is 1 1 1 and here it is 0 and carry. So what we have to do? We have to add the carry onto the left LSB. So now I am adding the carry here. So this is a carry. This is a carry. So 1 1 1 0 1 1 1 0. So this is the result of B1 plus B2. Okay, B1 plus B2. Now what we have to do? So I'll write here B1 plus B2. So there's a ones complement. Now what we have to do? The result of B1 plus B2, we need to apply the B3. So B1 plus B2, which is 0 1 1 1 0 1 1 1, and B3, which is 0 0 0 0 1 1 1 1. Ones complement arithmetic. So it will be 0 and 1, and again what happens here? 1 and 1 and 1 and 1, and here again it's 0 and 1, 0 and 1, 0 and 1, 0 and 1, and here it is 1. Okay, so if it is 3, okay, if it is 3, we'll be getting 1 and carry 1. See, I'll write here. So if it is 0 plus 1, we'll be getting 1. 1 plus 0 again, we are getting 1. 1 plus 1, we'll be getting 0 and 1 as a carry. And if we are applying 1 plus 1 plus 1, we'll be getting 1 and 1 plus carry. Because see, the representation 8 4 2 1. So here it is 1, here it is 1. If it is 2, 2 means, see, 1 and 0. So that will be carry. And if it is 3, 1 and 1. So 1 will be the result and 1 will be the carry. Sorry. 1 will be the result and 1 is a carry. So the same way we are applying. Hope you understood this one, right? So we are getting this one, right? So this is B1 plus B2 plus B3. Now we have to apply this one. So 1 0 0 0 0 1 1 0. So this is the same thing, right? And with this the last one. So 1 1 1 1 0 0 0 0. So 0 1 1 0 1 1 1, and here it is 0 and 1 carry. So this should be added to the LSB. So I'm adding to the LSB. How much we are getting? So here it is 1 1 1 0 1 1 1 0. So this is the result. Okay. So what is the result of B1 plus B2 plus B3 plus B4? So what is the result? 0 1 1 1 0 1 1 1. Okay, this is the result. So what we have to do? We have to apply the ones complement. After applying ones complement, after adding all these things, we have to apply the ones complement. So which will become 1 0 0 0 1 0 0 0. So because it becomes 1, it becomes 0, it becomes 0, it becomes 0, 1 0 0 and 0. So this is the ones complement. So ones complement is this one. And what we have to do? So we have to add this one to the data and it should be sent to the receiver. So during in the receiver, see again, I'm writing here B2 1100 1100, B3 0000 1111, and B4 1111 Okay, and checksum. What is the checksum here? So whatever the result we are getting and one's complement, this is the checksum 1000 1000. Okay, now what we have to do? We have to again add all these things. So far we have added all these things and we got the result as this one, right? This one. And for this, if you add this one and do the ones complement, you need to get zeros. Okay, so the same, perform all the same things. So I have performed all the things here. So B1 plus B2 plus B3 plus B4. So how much we got? This one. 0 1 1 1 0 1 1 1. So for this we need to add the checksum also. What is the checksum here? We got checksum 1 0 0 0 1 0 0 0. How much? 1 1 1 1 1 1 1 and 1. And we need to apply the ones complement. We need to apply the ones complement. So if you apply the ones complement, what we got? So all zeros we are getting, all zeros. So if we are getting all zeros, that implies there is no error during the transmission. You can observe B1 is same, B2 is same, B3 is same, B4 is same, and checksum we have said. For example, if there is any modification in this data, okay, if there is any modification in this data, let us check. See, in B3, instead of getting all 4 zeros and 4 ones, so if the data is in this way, okay, if the data is in this way, if the data is received in this, now what happens? Again, apply the same B1 plus B2. So B1 plus B2. So 1 0 1 0 1 0 1 0, and B2 1 1 0 0 1 1 0 0. So you can apply 0 1 1 0 1 1 1 1 0 1 carry. So I need to add here 1 1 1 0 1 1 1 0. Now I will add a B3 also here. So B3, I am adding B3 also here. 0 0 0 0 1 1 0 0. How much? 1 1 0 1 0 1 0 1 0 1 0 1. I am getting B3. Next, add B4. 1 second. 1 1 0 1 0 1 0 1 0 1 0 1, and here it is 1. Okay. Now add B4. Add B4. What is a B4? 1 1 1 1 and 0 0 0 0. How much? 1 1 0 0 1 1 1 0 and 1 carry, and this should be added here. 0 1 0 1 1 0 1 1 1 0. So this is the thing we got. And checksum, we also have to use a checksum. What is the checksum here? 1 0 0 0 1 0 0 0. We need to add the checksum also. Okay, we need to add the checksum also. So 0 0 1 1 1 1 1 and 1. Okay, so this is the result of checksum, right? Now we need to apply the ones complement. Ones complement of result. What is the result here? So result is 1 1 1 1 1 1 0 0, and here we are applying the ones complement, which becomes 1 1 0 0 0 0 0 0. So this is the ones complement. So if we are getting all zeros, that implies there is no error corruption, right? There is no modification of error. But here we are getting to non-zero value. It's a non-zero value. So if we got the non-zero value, that implies there is an error during the transmission. You can observe in B3, in this block B3, in the sender we are having 4 zeros and 4 ones. In the receiver we are having 4 zeros, 1 1 and 0 0. That means here 2 bits have been corrupted, 2 bits have been changed. So for that reason, if you apply the same procedure on the receiver side, we are not getting all zeros. If you got all zeros, that implies there is no error. Okay, so this is how we can detect the error. Okay, the error detection can be done. That means whether any bits have been corrupted during the data transmission or not. So here it is a simple example. So hope you understood. Right? So if you are having any queries regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.